the way we handle data is changing, and it's changing fast. It's not just about writing code anymore. Now we're almost directing these autonomous entities to do the work for us.
We're talking about data agents. These are the systems, really, that are designed to orchestrate these big, complex data and AI ecosystems, all driven by the power of large language models.
It's a really exciting space, but the sources we dug into for this deep dive point to a pretty fundamental problem right at the start.
They do. It's an issue of terminological ambiguity. The term data agent itself is kind of a catch-all right now.
A catch-all how?
Well, it's used to describe everything from a simple chatbot that just spits out a single SQL query,
Okay.
all the way to these highly sophisticated architectures that can autonomously manage an entire workflow. They're just not the same thing.
Right, and if the industry can't even agree on what a data agent is, why should you, our listener, really care? What are the actual risks of this confusion?
The risks are significant. I mean, we're talking about both operational and, frankly, legal risks.
Go.
First, you get these dramatically mismatched user expectations. A user might think their simple L1 assistant is this super smart L3 orchestrator, and they might trust an output that they really should have checked themselves.
And that could lead to huge problems.
Huge. And second, and maybe this is even more critical, it makes accountability almost impossible to figure out.
So, if a data pipeline fails,
Who's responsible? Is it the human operator because they misunderstood what the system could do? Or is it the vendor because they sold a flawed system with a poorly defined capability? It gets messy.
so what we need is a clear, universal way to classify these things. Sort of like what the auto industry did for self-driving cars.
That's the solution the sources propose. A systematic, hierarchical taxonomy running from L0 up to L5. It's analogous to the SAE standard for vehicle automation.
And the goal is to define the boundaries.
To define the capability boundaries and, critically, to establish where responsibility sits at every single level.
So our mission for this deep dive is to use that L0 to L5 taxonomy as our guide. We'll use it to map out the progression of these agents across the whole data lifecycle, data management, preparation, and analysis. Let's start at the beginning then. Walk us through these 6 levels. The core idea, as I understand it, is this gradual handover of control from the human to the agent.
Right. We start at L0, no autonomy. This is the world we all know. It's entirely human-driven.
The solo practitioner.
The solo practitioner. You're writing every SQL query by hand. You're coding every cleaning script. You're manually tuning every knob on the database. No agents involved in the actual work.
Then comes the first real step.
The first real step is L1, assistance. Now, this is a very simple, stateless prompt and response setup.
Like a basic assistant.
A nascent intelligent assistant, yeah. It generates something useful, a Python script, some advice, but it's crucial to understand it's an open-loop system. The human is still in charge of taking that output, executing it, and verifying it works.
Okay, that brings us to L2, partial autonomy. This feels like a much bigger jump because now the agent can actually perceive its environment.
That's the key word, perception. It moves beyond just responding to a prompt. It can actually connect to a data lake or a code interpreter or APIs.
So it can see what's going on.
It can see what's going on. L2 agents become procedural executors. They can follow steps and adapt, but, and this is important, they operate within a pipeline that a human has already set up.
Yeah.
The human still owns the overall workflow.
So if L2 is about the agent following procedures, then L3. Conditional autonomy must be where that power dynamic really flips.
It absolutely flips. L3 is the critical point where the data agent takes on the dominant role.
Dominant how?
It's autonomously orchestrating and optimizing complex data pipelines, maybe even spanning all 3 stages: management, prep, and analysis. The human's job changes from operator to supervisor.
So you're just watching over its shoulder.
You're monitoring, ready to intervene if something novel or high risk comes up, but the agent is doing the driving.
Then we move beyond supervision to L4, high autonomy. What defines this level?
Sustained self-governance. At L4, you don't need routine human supervision anymore. The agent doesn't even need explicit tasks.
It's proactive.
It's proactive. It might continuously monitor for data drift, for instance, and then decide on its own to launch an investigation pipeline. The human is just a passive onlooker, really, just getting reports.
And that leads to the final, almost theoretical endpoint, L5, full autonomy.
This is the ultimate stage. It's about generative intelligence. The agent isn't just executing tasks, it's capable of inventing completely novel solutions, pioneering new methodologies. It functions like an expert data scientist, making human involvement unnecessary.
Okay, that's the framework. So let's zoom in on that first Major leap. L0 to L1, the move to assisted intelligence. We're going from doing it all yourself to using this simple assistant. What's the biggest weakness of these L1 systems?
The core limitation is that they're stateless and open loop. They give you a response based on your prompt, but they have zero awareness of what you do with it next.
Can you give us an example?
Sure. In data analysis, think about NL2 SQL systems like Den and SQL. They're pretty clever. They can break down a request into subtasks to generate the right SQL,
But
but the SQL code it produces has to be manually validated and executed by the user. The agent doesn't check its own work. It can't.
and I imagine we see that same pattern in something like data preparation.
We do. For data cleaning, systems like RetClean or Lakefill use a technique called retrieval augmented generation, or AIR, to fill in missing values.
Which is a classic L1 task.
A classic L1 task. It intelligently looks up examples to make a good guess, but it's totally passive. If the data it cleans causes a validation error downstream, the agent is blind to it. A human has to find the error, figure out why, and then go back to the agent for a new suggestion.
So that need for manual detection is the signature of L1. The human is still the one responsible for all the verification. Which brings us to the next big jump. L1 to L2, gaining perception. It sounds like this is the point where the agent finally learns to check its own work.
That's a great way to put it. The L2 agent connects to its environment, which allows for these internal, closed feedback loops.
How does that look in practice?
A great example in data preparation is a system called IDERClean. It actually has two internal parts: a repairer that cleans data and a detector that checks the repairer's work.
So it's a loop.
It's a closed loop. If the detector finds errors, that feedback automatically triggers another repair cycle. The human isn't in that immediate correction loop at all.
And for data management, like optimizing a query.
We see similar loops, maybe with external tools. The Quate system, for instance, tries to rewrite a slow query. It then uses an external tool, like a SQL solver, to verify the new query does the same thing as the old one.
And it checks performance too.
It does. It defines a reward function based on actual execution time. So that environmental feedback, how fast it's running, guides the agent to get better and better. That's pure L2 procedural autonomy.
So whether it's IDERClean or Quite, the L2 agent is running a specific procedure on its own, and it's using feedback to adapt. But what stops it from being L3?
It's still operating within a workflow that the human created. The human says, clean this data or optimize this query. The agent executes that one instruction very well, but it doesn't decide what the next big step should be.
And that's the leap to L3.
That is the crucial transition. The leap from L2 to L3 is about the transfer of task dominance. The agent goes from just running subtasks to orchestrating entire end-to-end pipelines based on a high-level goal from the user.
Now, we are starting to see what the sources call proto-L3 systems pop up. They're coming out of academia systems like agentic data and also from big industry players like Databricks and Google.
That's right.
But if they're designed to build the whole pipeline, why are they still proto? What's holding them back from being true L3?
The sources point to two main challenges. The first is what they call limited autonomy in pipeline orchestration,
Meaning?
meaning many of these systems depend on a toolbox of predefined, hard-coded operators. Even the more advanced ones, like a system called JoyAger that has tool evolution, are really just finding clever ways to recombine existing tools.
So they can't invent something truly new on the fly.
They can't. They aren't demonstrating what's called ab initio creation. They can't invent a new algorithm from scratch. Their orchestration is still tied to the parts they were given.
They're great builders with a specific set of Legos, but they can't invent a new kind of brick.
That's a good analogy. And the second major hurdle is incomplete coverage of the data lifecycle.
Okay, what does that mean?
Most of these proto-L3 systems are really focused on the glamorous downstream work. Data analysis, visualization, modeling.
They're skipping the hard parts.
They're skipping the crucial low-level data management tasks, things like index management or database configuration tuning. Their expertise is limited to working with data that's already been prepared for them.
A true L3 agent would have to be able to do it all.
It would need to be a versatile expert across the full life cycle. If it can't diagnose a system problem or tune a configuration, it can't really claim dominance over the entire pipeline.
This taxonomy is a really useful way to look at the field. It makes it clear that even the most advanced systems we have today are still pretty constrained, both by the tools they're given and their narrow focus.
And that's the real value of this L0 to L5 structure. It gives us clarity, it lets us assess developments honestly, and it clarifies who is accountable legally and operationally at each level.
So if we look beyond L3 for a moment, we said L4 high autonomy is about autonomous problem discovery. The agent finds its own work. And L5 full autonomy is generative innovation. So what does this all mean for the road ahead?
The research suggests that the big jump from L3 to L4 really depends on solving a fundamental reasoning problem.
Which is?
L2 systems are great at what you'd call tactical error correction. They fix a problem in a defined procedure. But to get to L4, to make long-horizon decisions and proactively find problems, agents need much more sophisticated memory architectures.
They need to remember more than just what they did.
A lot more. They need to move beyond just storing a history of execution steps. They have to support abstract strategic knowledge.
Strategic knowledge.
They need to understand why a certain pipeline was run, what the overall business goal was. It's only with that kind of strategic memory that they can move past short-term fixes and achieve true self-governing autonomy over long periods.
So agents need to develop a deep, almost philosophical understanding of their own mission. That is a fascinating challenge for the future of data agent design. A perfect place to end this deep dive.